Okay, so this is a new video, and it's kind of inspired by, I've been reading the Tao Te Ching, and there's this principle in Taoism of returning, that one watches the, returning. And as I was thinking about that, I realized some things, like for instance, that every force returns precisely because it is spinning. So what you have here is spinning forces result in returning, recurring, or cyclical forces or patterns or whatever you want to call it. So if you look at this, every time a force, all forces spin. So all forces spin, but since they're spinning, they have these arcs that ultimately bring them back around to their original point of origination, essentially, because they're precisely because of their spin. Now, I mean, that's a simplistic way of looking at it, but there may be more to it than that. But one way to look at it is that cyclical forces are recurring or doubling spin forces potentially. So what you have here, you have this spin force going around, but then it becomes another spin force again, and that may account for many cycles that we see in nature. Not just the recurring of something once, but this, recurring of something again and again and again. But also there's this other kind of pattern that occurs, which is a little bit different, which is spin forces are dispersed, divided, and absorbed by counterspin forces. So you have this primary spin, then what you have is all of these counterspin forces branching off at every point, and you can see this is the same kind of pattern you see in nature. And so in a certain sense, this is the same principle as these others of the returning kind of thing, in the sense that here's this primary spin, but then it's dispersed, divided, and absorbed by all these counterspin forces, so it kind of returns to the original state in some sense. So these are just, things I wanted to add to everything. Spinning forces result in returning, or recurring, or cyclical forces. Cyclical forces can be or are recurring or doubling spin forces, and spin forces are dispersed, divided, and absorbed by counterspin forces. So that's it. Thanks.